Right, we're going to find unknown lengths given two similar shapes where one is inscribed and the other requires subtraction. So we've got to find this length here. Okay, so we can't use just similar shapes and scale factors to find this one, because we can use that to find this length and then subtract the 7 from it to get this length. So looking at the common mistakes, unfortunately, the people who made this mistake and this mistake, none of them wrote their working down, so I can't see where they went wrong. On this one, the 18.2, we can see the working here, and you can see actually on both of them the working is not that great, but they correctly identify the scale factor. And what they then just do is they just do 7 times the scale factor and leave it at that, but they've worked out this whole length here. So going through this, okay, we can find the scale factor of enlargement, okay, from this small triangle to this big triangle as 28.6 divided by 11, and that gives me 2.6. Now, we want to find this whole length here, so let's just call this whole length x. So x will equal 7 times 2.6, which comes out to be 18.2. So therefore z must equal 18.2, this whole length here, minus 7, which comes out to be 11.2. Right, so on this question, we have the volumes of two mathematically similar models are in the ratio 1 to 216. So for each 1 unit in the volume of the small one, you have 216 as your volume of your big one. So you're going to times by your scale factor here, your volume scale factor, should I say, is equal to 216. And the surface area of the smallest solid is 340. Now, these ones never wrote their working, but I've worked out they've just times the 340 by 216. But this is area and this is a volume scale factor, so they've used the wrong scale factor here. And then on these two, we can see this person has actually worked out, I think they have square rooted this. Okay, and that's the volume. And what they need to do is they need to cube root this to find out the length scale factor. Okay, if you cube root this, you get the length scale factor, and then square it, you get your area scale factor. But what they've done is they just square rooted this to go from volume to area, which is not the right thing to do. So if you want the volume scale factor, the first thing we need to do is work out the length scale factor, and that is the cube root of 216, and that comes out to be 6. So therefore the area scale factor will be 6 squared, which gives me 36. So to find out the surface area of the larger solid, what we have to do is we need to do the 340. So the area must be equal to the 340 times by 36. And that comes out to be 240 centimeters squared. So remember, to go from volume to area or area to volume, first of all, go through finding the length scale factor first. You either cube root volume to get length scale factor, or square root area scale factor to get length scale factor, and then cube or square to get the other one that you need when you're moving through that.